Hey guys, welcome to Zeros of Polynomials. And today we're going to be finding zeros from higher order polynomials using graphs and synthetic division. So if you guys watched the last video, we found zeros of polynomials. We found them from factors, we found them from graphs, as well as we found them from quadratics. So this video is going to kind of take a step upwards. And now we're going to look at finding zeros from equation form. And all of our equations are going to have higher than degree 2. And we're going to use synthetic division to help us out here. So let's get going. So there's a couple different scenarios we can run into. And one of them is, well, what if we were very nicely already given 1, 0, right? It's basically like a gift. So in this problem, given that x equals 2 is a 0, and let's remember what that means. That means if I plug in 2 to my function, everywhere where I see an x, I will zero out the function. Okay, it'll equal 0. That's why it's called a 0. So if we already know that x equals 2 is one of the zeros, what we need to do is find the other 2. What we're going to use here is we're going to use synthetic division. Now why? Well, if I know that x equals 2 is a 0, I know x minus 2 is a factor, and what synthetic division can help us do is if we know one of the factors, we can find the other 2, 3, 4, 5, however many. Okay. So what we're going to do is we're going to use this 2. We're going to put it in our box and start our synthetic division. Now we take the coefficients of each variable. So we have a 1. We're going to take a 1, a 2, a negative 5, and a negative 6. A 1, a 2, a negative 5, and a negative 6. Now we start our synthetic division process. First number drops down. 2 times 1 is 2. Add. 2 times 4 is 8. Add. 2 times 3 is 6. Add 0. We should get a 0 because we know that 2 is a factor. We know that 2 is a 0. So we should get a remainder 0 here. So what we have so far then, so how do we rewrite this as a polynomial? So drop the power by 1. So this is going to be 1x squared plus 4x plus 3. So now we know our polynomial is going to factor into x minus 2 times x squared plus 4x plus 3. And we know that 2 is the 0 of that factor. So now we have a quadratic. So going back to the last video, well, how do we get the zeros out of a quadratic? Well, we have a couple options. We could use quadratic formula, or we could factor, or we could even graph it. So we have like 3 options here. Well, I can see that this thing will factor, right? Because 2 numbers that multiply to 3 that add to 4 will be 3 and 1. So this will factor to x plus 1. This will factor to x plus 3. And now from my factors, I can get my zeros. So my zeros are positive 2, negative 1, and negative 3. And done. So my other 2 zeros here were negative 1 and negative 3, and I used synthetic division to find them because one of my zeros was already given. So that's one of the scenarios you could run into. Another scenario you could run into is you're given a polynomial, and you're not given any zeros off the bat, but you notice, hey, I can factor this thing. And we know that factors can lead to zeros, okay? So that's kind of a key here. So I notice we can factor this thing because, look, every single term has an x. So let's use greatest common factor. So let's pull an x out of every term. This will go to x squared. This guy will go to negative 6x. And this guy will go to negative 16. Okay, and now we're back down to a quadratic. And once we get to a quadratic, we're golden because, again, we can graph it, or we can factor it, or we can use quadratic formula. So we have 3 different options here for finding the zeros. This guy looks really nice again, so I'm just going to continue factoring. So 2, since our leading coefficient here is a 1, we can play the game of 2 numbers that multiply to the back number that add to the middle coefficient. So 2 numbers that multiply to negative 16 but add to negative 6. This is going to be negative 8, and it's going to be positive 2. Right? Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So now I know my zeros are, this we can think of a factor as x minus 0 parentheses. whenever you see a variable by itself, whether it's x, whether it's x squared, whether it's 5z to the 5th, our factor here will always be 0, right? How do I make that equal 0? Well, I actually plug in 0. So 0 will be 1, 0, the lots of zeros. Positive 8 will be our next 0, and negative 2. So our zeros of this polynomial is going to be 0, 8, and negative 2. So again, this situation we had no zeros given, but we factored it and we figured it out that way. So again, what if there's no zeros given, but now you're like, whoa, I don't know if I can factor that thing. That thing is nuts, right? So you're like, I don't know about this. So what could we do? What's the next strategy that we have at our disposal? Well, graphing, right? Because what do we know about graphing? We know if I graph a polynomial and I can find its x-intercepts, we know that the x-intercepts and the zeros are connected. So let's do exactly that. So I'm going to go into my graphing calculator, which I already very nicely and neat have teed up here. So this is our green graph. So let me see, can I find any nice zeros? That is not a nice 0. That is not a nice 0 because it's not... Or sorry, this is what I want, this 2, 0 right here. My apologies, I don't know what I was thinking. So this is the 0 that we're going to use here. So we found that we have a nice intercept at 2, so that also means we have a 0 at 2 as well. So we figured out one of our zeros, so we know that x equals 2 is a 0. We know that because we graphed, and that was our intercept. So kind of doing the same thing we did in the first example now, let's throw it into synthetic division. So we know 2 is a 0, so we put it in the box. Our synthetic division numbers are going to be 1, negative 2, negative 5, and 10. 1, negative 2, negative 5, and 10. 1 drops straight down. 2 times 1 is 2. That'll give us 0. 2 times 0 is 0. That'll give us negative 5. When we add together, 2 times negative 5 is negative 10. Add these together, get 0. Great. This is a 0 because when we threw it into synthetic division, we got a remainder of 0. So perfect. So what do we have then? So we have dropped the power by 1. So this is x squared plus 0x minus 5. So that's one factor. We know 2 was a 0, so x minus 2 was another factor. So now what do we do with this? Again, a couple different options. We could throw it into quadratic formula, but what I'm going to do is factor it. I'm going to use difference of squares even though 5 isn't a square. So I'm going to use the difference of squares formula like so. So because x squared is a square, so I'm going to kind of force this. We know our last factor is x minus 2. All of this equals 0. So the square root of the first term is x. We know we throw a plus minus in. Now we need a square root of the second term. So what is the square root of 5? Well, it's exactly what you think. It is the square root of 5. So my zeros here then are x equals 2, x equals negative square root of 5, and x equals positive square root of 5. Okay, I played like a tricky difference of squares game here, but you could have used quadratic formula. Graphing would have been difficult because it would have given you decimals and the square root of 5 would have been as apparent. But remember, you always have quadratic formula at your disposal, so that could have been something else you could have done here as well. All right, and our last example. So in our last example here, so same thing. We have no zeros and we can't factor. And this thing looks pretty hairy. And I'm like, I don't know if I can factor that thing. So whenever you can't factor, graph, right? So let's graph it and maybe our graph will be a little more illuminating. Not this one though because it's the wrong graph. So we just did that one. So let's look at this guy here. So this is our equation. I'm going to put this over here. Let's zoom out a little bit. See if we have any other zeros we can see. Oh, look, there's another one. So let's see what we got here. We got a 0 at 4 and negative 4, so that's useful, and that's gargly goop, so that's not going to help us so much. But we know we have a 0 at 4, and it looks like we have a 0 at negative 4, so I'm going to use those. So thank you, graph. So I know I have a 0 at 4, and I know I have a 0 at negative 4, thanks to the graph. I also, and we'll get into this a little later, according to fundamental theorem of algebra, I know I'm looking for one more 0. So let's see exactly what that could be. So I'm going to use synthetic division, and I'm going to use either of these. It doesn't matter because they're both zeros. So 4 goes up in the window. 3, negative 4, negative 48, and positive 64. So 3, negative 4, negative 48, positive 64. The 3 drops down. 3 times 4 is 12. Negative 4 plus 12 is 8. 4 times 8 is 32. Negative 48, positive 32, that's going to give you a negative 16. 4 times negative 16 is negative 64. Those guys zero out. Perfect. So our leftover polynomial then is going to be drop the power by 1, so 3x squared plus 8x minus 16, and the 0 I just used was x minus 4, right? If x minus 4 is the factor, then positive 4 is the 0, right? So that's the factor for that 0. Okay, so I have this, but I also know this, right? I know that I have another factor of x plus 4, right, from my graph. So this guy here is going to break down to x plus 4 times something, but I don't know what it is. So how could I figure that out? Well, that's exactly what synthetic division is good for. So I know this is a factor of that. How could I find the other factor? So let's do synthetic division again, but I'm going to use it with this quadratic. Okay, so negative 4 now goes up in the window, and 3, 8, and negative 16 go here. 3 drops down. 3 times negative 4 is negative 12. 8, negative 12, that'll be negative 4. Negative times a negative now is a positive 16, and that goes out to 0. So my factor here is drop the power by 1. I started with a quadratic, so I'm going to end with a linear. So it'll be 3x minus 4. Okay, so that is precisely what's going to go in there. So I can erase that because now I know that's going to be 3x minus 4. So my zeros now are at x equal 4, x equal negative 4, and if I set 3x minus 4 equal to 0, so let me just do that work up here real quick. 3x minus 4, I set that equal to 0. I add 4 on both sides, and then I divide by 3. X will equal 4/3. So we actually even saw this in the graph when you saw that 1.33333, and I said this is gargly goop. It really wasn't. That can be written as a fraction as 4/3. So we did actually see our other 0 in there. So here are our zeros here. So this was a little bit different. We used synthetic division twice. What we could have also done is we could have thrown that into quadratic formula. We could have graphed it. We could have factored it, actually. Yep, we also could have factored it. So there's many ways to go about these. And actually that brings up my last slide. Maybe it does. Yes, it does. Here it is. So that brings up my last slide here, which is there's many ways to do these problems. So it's not just a one-step kind of cut and dry, like you're always going to do it this exact same way. But there is some strategies that you can use. My first strategy that I love is factoring, because if you can factor it, going from factors to zeros is really easy, it's really clean, and it's really nice. So I always like to factor if I can. If I can see an easy factorization, I'll use that. If I can't see an easy factorization and I need to try to get A0 for the sake of this video, try to graph it then and look for an x-intercept. Look for a nice whole number x-intercept. In a different video I go through rational root theorem. So if you're interested in looking at that, that's a way to find your first zero without graphing, supposing that there is a rational root there. So that's another strategy that's not in this video. That's a little more of an advanced technique. But if you want to go check that out, just go check out the YouTube channel and you can see that. Then we use synthetic division and we use quadratic formula as well, right? Once we get our zero, then we throw it into synthetic division. We try to whittle our way down until we get a quadratic. Once we get a quadratic, we can graph it or factor it, or we can use quadratic formula to find our other zeros. Okay, so factoring, graphing, synthetic division, and quadratic formula, these all have to be really strong before you can try to find these zeros, because you're just going to repeatedly use these four strategies over and over and over and over and over again. So I hope you guys enjoyed this video, and I hope that helped. And as always, please, whenever you guys have questions, please just ask.